A warm welcome to all my dear friends and students. A very good morning, good afternoon, good evening to all of you. And this is the DADM2, which is Data Analysis and Decision Making 2 lecture series under NPTEL MOOC. And we are in the second week, and as you can see, this is lecture number 7, which is the second class in the second week. And as you know, this total course DADM2 is for 12 weeks. And the total number of hours is 30 hours, and total number of lectures is 60 lectures, because each week we have 5 lectures, each for half an hour, and after the each week classes we have assignments. So, we have already finished one set of assignments after week 1, and we will soon go for the week 2 assignments. And as you know, my name is Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember the last slide which we were discussing in lecture number 6 was basically to find out the actual characteristics of the utility function. So, we have considering we have no information about the utility function. So, based on that I proceeded, I did discuss, and I also did mention in the last few minutes of the last class that I will again come back to the same slide and try to discuss the same points once again. Maybe for some of you it may be repetition, but I think it will be good that if you discuss, so you understand at least in a very simplistic conceptual way how this whole idea can be utilized in order to basically proceed forward and find out about the utility function. So, this is the slide which I have, and along the y axis we have values of C, and now the C values are the certainty values. So, they will change depending on the problem which we have. So, let us be aware of that, point 1. Point number 2 is that along the x axis we have basically the values of the gamble, which based on which we are trying to find out the C values. So, the values are A and B can be changed, and we are considering a fair gamble in the sense the probabilities of the coin coming a head or the coin coming a tail are equal, then they are half. So, let us basically do the thought out experiment and whatever it is this graph signifies. Also note the blue line, which is 45 degrees line, is drawn in order to make us understand that what type of utility function it is which we are going to basically draw depending on the response from the person who is taking a decision. We will come to that very soon. Consider A and B are assumed as they are given in this slide. So, let me just highlight it. So, this is A, this is B, the values are given. Now, consider that it is a fair gamble, probability is half. So, you will basically have A into half plus B into half, it will be A plus B by 2. So, that will be a straight line in between, midpoint between A and B. So, let me use a color, let me use the red color. So, and it is bold because it is now we know the expected value. And once we reach the 45 degrees line, what we do is that we go horizontally onto the left and mark this value as, say for example, C1. So, now the experiment goes like this. On table 1 on the left hand side we have A and B, and we have a coin which is probability half and half, and on table 2 which is on the right hand side we have the so called C1 value. We do not know whether C1 is a certainty value till now. I am using the symbol C, but that is just for the nomenclature's sake, but we do not know actually it is a certainty equivalent for that person who is going to make the decision. So, we call that person, ask him that there is a fair gamble with values A and B, probabilities and half, and on the right hand side there is a value of C1. So, what is his or her decision? If the person is indifferent between the fair gamble and the C1 value, then be certain that the C1 value which is kept in front of him is the certainty value, because he is taking a decision based on the expected value of the gamble and the certainty value. So, obviously, that is on the straight line. So, we will assume that the person has a utility function which is linear, which is uw is equal to w. Now, that is just an hypothetical case. Consider the other two cases and which are more likely. The person says that no, he is going to take the gamble. In that case, it means the certainty value based on which he will take a decision whether to take that gamble which is given in front of him with values a and b, and the value of certainty on the right hand side, that C1 is not no more a certainty value for him, remember that, because the expected value which he has and the certainty value which he assumes to be would be in such a way that the certainty value is now C2, which can be, say for example, greater or less than C1. I will come to that why it can be greater and less than C1. So, if it is greater than and less than or less than C1, then the values of C2 which we are assuming would be either above this 45 degrees line. So, I will basically populate that with some, okay. If it is greater, so no, green will not do, sorry, I will use the yellow color. So, if C2 is greater, they will be in this region, and C2 is less, which is below C1. So, the values would be here. Which technically means that the utility function which we are talking about would obviously have a first derivative as greater than 0, because as the non-satiation characteristics, but greater than C1 and less than C1 basically in the long run, as you basically play this game repeatedly, would mean basically the u double dash which is there for that person is either concave or convex, in the sense that u double dash can be greater than 0 or less than 0 depending on whether the person wants the risk or does not want the risk, that would basically come out. Now, what you do is that keep changing a and b. So, change a and change b also, but do not change the probability, if it remains a fair gamble. So, obviously, C1 value changes, so which is the expected value of a and b taken, and again you ask the person that whether you want to take that new value of a and the new value of b, which is now a1 b1, or the certainty or the so called fixed value which is kept on the table on the right hand side. Consider that is, say for example, C1 dash, and let us again ask him or her what is his or her decision. Consider the person is going to take a decision such that the certainty value for him is greater than C1 dash or less than C1 dash. So, again you will have a set of value which is above the blue line 45 degree lines or below the 45 degree lines. Again change a and b, that means now they are not a1 and b1, they are a2 and b2. Again find out the expected value which is now C1 double dash. So, these dashes do not mean derivative, remember that I am just giving a symbol. Again ask that person, he says again that he is either greater than C1 double dash or less than C1 double dash depending on the certainty value which is true for him or her, mark that point. So, as you continue doing as you continue taking different values of a and b, you will have different values of C1 dash or C1 double dash and C2 double dash, so on and so forth. The certainty value of that person would also keep changing. So, if you plot them, you will have either a set of points which are over the 45 degrees line, which is the blue one, or below the 45 degrees line, and if you join them you can find out whether it is a concave function or a convex function, which means it will give you this. So, this would give you the rate of change of the utility function, and you can also find out the double derivative based on which you can immediately find out the important points, which are, if you remember, I have mentioned that there is a characteristics of a and a prime, there is a characteristics of r and r prime, which are basically absolute risk aversion function and relative risk aversion function. Based on that you can find out what is the characteristics of the utility function, such that you can say whether the utility function is quadratic, whether it is basically, say for example, exponential, whether it is logarithmic, whether it is power function, so on and so forth. So, without knowing the actual characteristics of the utility function, you can do a very simple experiment, find out the characteristics, and you may comment something about the utility function based on which you are going to work, or what is the utility function of the person to whom you are basically posing these questions. So, this is what the analysis what I discussed. I will again mention it. A and B are wealth values, some amount of wealth, values of the wealth, which is basically W. Also, for the ease of our analysis, we consider that the utility function is W, which is linear, which we have already discussed. Form a lottery that it has an outcome of A with a probability P and an outcome B with a probability 1 minus P. In this case, to make our life simple, I have said that the probabilities P and 1 minus P are half, that is a fair gamble. So, that is the ease. You can change this half and half, which are the probabilities, to P and 1 minus P, or to P and Q, and this P and Q need not be half, they can be in different values, but we are not going to discuss that, because they just will only make things a little more intense, but the overall analysis remains the same. The third point mentions change the values of P and ask the investor how much certain wealth or C he or she will have in place of the lottery. So, basically lottery is placed, and on the other hand that value C1 is placed, whether that some amount delta amount has to be removed from C1 or delta amount has to be added to C1, such that the person is indifferent between the lottery and the amount of value which is kept on the right hand side of the table. So, obviously, in that case the person would have a certainty value, because he is balancing the utility which is he or she is getting from the fair gamble, and what he or she is basically getting from the right hand side of the table, which is basically the fixed value. Now, the expected value of the lottery, as now P and 1 minus P are different. So, let us continue with that. The expected value of the lottery are P into A plus 1 minus P into B, which is the utility. So, I will mark it. So, this is the utility. We are considering, remember, why the question may come up, why we are considering A as the utility of A, because we are considering a uniform utility function, UW is equal to W. If it changes, obviously it will change accordingly. A risk averse person will have the value of C is less than he does not want to take the he is risk averse. Wait, let me check. A risk averse person will have, yes, in that case the person would have a value such that, just let me check. Yes, I think there is some, it would be, check 1 minute. It would be a risk loving, sorry my mistake, a risk loving person would have where the expected value of the lottery would be more than C, because he is willing to take the risk. So, in that case P into A plus 1 minus P into B, the overall value would be greater than C, because the person is willing to take the risky decisions. Now, you plot the values of C and you have already have expected the values of the lotteries which is given. What you do is that keep plotting the expected value, keep plotting the actual value of C based on which the person will be indifferent. Once you plot them, they would be either along the straight line, which is the 45-degree line, a set of curve which is over the blue line, and on a certain or a certain of values which are below the blue line, which is the 45 degrees line, and you can find out what is the characteristics of that human being who is taking a decision, whether he or she wants to take a risk, whether he or she is indifferent to risk, and whether he or she is basically wants to avoid the value of risk. How would you find the explicit form of the utility function of a person? Suppose you know that it is of the form UW is equal to the exponential part, which is minus e to the power minus AW. Now, here the point is utility function is given, which is exponential, but we do not know the value of A, we have to find it out. You ask the person that given a lottery which has a 50-50 chance of winning, which are the values are 10 lakhs and 40 lakhs, 4 lakhs sorry. So, 10 lakhs and 4 lakhs. In order to buy this lottery, what was he or she willing to pay? Now, you put that answer to that person and you know that person has an exponential utility function. And say for example, the person says that the lottery is there 10 lakhs and 4 lakhs and some amount is there on you want to keep a certain amount on the right hand side, and you know the person has an exponential utility function, but you do not know the value of A. Now, the person says that I am indifferent between the lottery and a certainty value, and the certainty value is say for example 5 lakhs, which would immediately give you the information that the expected value of the lottery and the expected value of the utility should match for that person, because he or she is willing to either take the lottery or take the certainty value, which is say for example, in this case is 5 lakhs. So, in that case what will happen, the expected value of the certainty value multiplied. So, in that case expected value would be like this, I will just mark it out where it is. Yes. So, it was 5 lakhs. So, obviously, the utility is this, I am just marking with the yellow color, and I will mark the certainty value with the yellow highlighter, and the probability is 1. So, the expected value of the right hand side is given, which is marked in yellow. Now, come to the other side, left hand side. So, the probabilities are half and half. So, the probabilities are given 0.5, 0.5. Now, what are the utilities, you will ask. So, one, the values of the wealth were 10 lakhs and 4 lakhs. So, the utility for 10 lakhs is given, utility of 4 lakhs is given, multiply each of them with given 0.5, 0.5, you get the expected value, balance that and find out the value of A. So, solving through iteration process, we can find out the value of A. So, let me continue reading it whatever is given, because I have repeated that, but I am still going to read it. Suppose the answer is 5 lakhs, which the person says, that then it means that the person is indifferent between a certain equivalent amount of 5 lakhs and the lottery, which is a fair gamble. So, you balance the fair gamble value, which is the expected value, which is given in red, balance with the yellow color, yellow marked expected value of the utility for the certainty value. Keep repeating this experiment for different values, find out different sets of A's, they would be changing because it is iteration process, and you find out the expected value of that and find out the best estimate, which is for the value of A. Now, there are few axioms of utility functions. An investor can always say whether A is, so consider I am an investor, I am a decision maker, and there are many different decisions in front of me. So, we will assume always that I am able to put my decision in such a way that either I am indifferent between A and B, whether I am willing to take A and not B, and vice versa. Number 1. Number 2 is that if I have 3 decisions and in case if A is better than B, better in the sense what is the utility or the value which is coming to me, B is better than C, then A would always be better than C. Now, here I would like to pause. In many of the non-parametric decision making process which you are going to consider, it may not be true, in the sense that my decision for favoring A with respect to B is more towards A, my decision for favoring A with respect to C is more towards A, but it may happen in the case let me put it as B and C. So, my decision for taking B with respect to C is more towards B. So, obviously, from the first information I know A is better than B, from the second information I know that B is greater than C, but it may so happen that the decision that A is better than C may not happen in many of the practical situations where non-parametric decision making are to be taken in practical sense. But to overcome that, we will continue considering this axiom that A is better than B and B is better than C would always imply A is better than C. We will continue doing that, and where there is a change I will notify that. So, this is an important point which I wanted to mention. So, these problems will be coming up. If you remember, I mentioned about data envelopment analysis, analytical hierarchy process, analytical network process, Electra, Topsys, Macbeth. So, all these processes which are non-parametric, different type of multi-criteria decision making, these type of issues would be coming, but I will mention that accordingly, so we can handle it. Consider the third axiom. It says that x is equal to y, then assume we can combine x with another decision z such that x with the probability of p and z with the probability of 1 minus p, such that on the same lines we have the same decision with z with y. So, in that case, if both of them the expected values are same, then in that case it will be x plus z is equal to y plus z, in the sense that the expected value which you are getting from combining x and z and the expected value which we are getting by combining y and z would give me the same utility based on which I am going to take a decision. That means, if there are two different sets of decisions for which the expected value are same, then I would definitely be indifferent between them. So, these decisions can be totally different. See, for example, in one case I want to build a factory in the city of say for example Lucknow, and another factory I want to build in, say for example, in city of Vijayawada, in near these cities. So, this is two decisions depending on many things. It may be depending on type of labor I get, type of raw materials I get, transportation cost, land acquisition cost, building cost, and all these things. And another case, consider I am able to build up another factory, another set can be near Pune and another one, say for example, near Bhubaneswar. So, in this both the cases, which is basically Pune plus Bhubaneswar, and other cases between the first example, we will consider these decisions in such a way such that the expected value or the general utility or the decision based on which you are going to take a decision of where to go for the first combination or the second combination would be such that the overall expected value or overall utility of the decision for the person who is going to take the decision would come out to be the same. So, obviously, if I take a decision and you take a decision for the same thing, it may not give you the same ranking of the decisions, because it may be possible that I like A and then I prefer B less than A, but your case may be that you prefer B more than A. So, obviously, the decisions would change because they would depend on the type of utility function the person has, the age of the person, the type of family background the person is, by the type of financial background the person is, what is the risk taking ability of the person. So, it basically depends on many intrinsics and not very objective criteria, but we will try to combine them as far as possible in the different type of decision making process which we have. There would be questions from your end which may not be very satisfactorily answered depending on when you solve the problem, but they are generally used in a different scenario cases such that we are able to tackle problems in a decently realistic manner. For every gamble there is a certainty equivalent, as I mentioned that. So, you have a gamble, fair gamble I would consider, but if it is a gamble where the probabilities are different, still we will have a certainty value. For every gamble there is a certainty equivalent such that a person is indifferent between the gamble and the certainty equivalent, such that the expected values for both the gamble, which is the fair gamble in our very simplistic case, and the certainty equivalent, the expected value would be the same. Now, consider comparison between the mean variance and the utility theory. So, what is the mean variance concept which you are considering? In the mean variance concept, we are considering that the mean, which is the first moment, variance is the second moment. We will always try to basically put the ranking of the decision based on the mean, that means from the maximum to the minimum, or the variance from the minimum to the maximum. So, if you take a ratio, as I mentioned in the first class or a first lecture, it will basically be a ratio of the mean to the variance, and we will rank them from the highest to the lowest. If it is the ratio of the variance to the mean, we will rank from the lowest to the highest and take the decisions accordingly. And the utility concept would be that we will see later on that mean variance concept would be true, and it will basically give us the same type of answers considering the utility function is quadratic. I will come to that later on, this is very important. So, comparison between the mean variance and the utility function. The utility function used is basically quadratic, which is uw is equal to w minus bw square, and there is no constant term for the time being. Actually, the quadratic function would have been a w minus plus bw square plus c. So, a, b, c would be the parameters, whether positive or negative, that is a different question. The utility function is used which is a quadratic function, and quadratic function would have some significance later on. Consider we have 3 assets and the prices are as follows. Now, Here if you look at the chart, what we are doing, this is again a hypothetical example, we are taking the numbers, that means the serial number depending on what is the outcome, and the decisions are A, B, C, and the prices are given as prices of the values are given like in the second column, third column, fourth column, corresponding to the fact that we are trying to find out the outcomes for A, B, C respectively. So, in the fourth, fifth and sixth, we are trying to find out the returns for A, B and C. The returns are given, because it will basically be returns can be, if we know. So, in one case I will use as I1 is the input which is happening for time period 1, and after some time period I get an output which is I2. So, I do not want to go into the exact values. So, there can be two type returns. Return capital R is I2 by I1, and small return would be I2 minus I1 divided by I1. Another one, in the case when you are considering the financial returns, we consider, so this is 1, 2 ln of I2 by I1. So, we will consider anything and then proceed. We are considering for the time being capital R. So, the capital R values are given for A, B, C. The probabilities we consider is 1/5, 1/5, 1/5 for all the cases. This is a simplistic case. Based on that, we find out the returns, average returns, that means add them up, divide by the number of outcomes. So, those are given R bar A, R bar B, R bar C, and the sigma, which is the standard deviation or the standard error for this sample for R A, R B, R C returns are given, again calculated. I am just putting it a tick mark so you can understand. Now, I consider the weights average to be given, which is 104, the wealth given as 114, 119 and 100. Based on that, we use the concept that what is the value that if the risk free interest rate is given as 0.5, then what is the mean, using the mean variance ranking system, I will rank them such that the values are greater than 0.5. So, I find out these values. Now, the issue is that if you use the utility ranking based on the quadratic concept, and if you use the ranking system based on the normative distribution such that you rank them over and above a certain probability, the ranking would always be the same. Reason being, in a very simplistic sense, quadratic utility function and normality of the returns go hand in hand. So, if the utility function in general is quadratic, your returns would be normal and vice versa. So, we are in a position where the normal distribution can be utilized, its properties can be utilized in a very big way, considering the utility function is quadratic. So, this slide which you are seeing, I will again consider this slide and the example in the next class, and with this I will end the class, considering the 30 minutes are almost over, and I would like to go into the details of these problems once more, so that you can understand and tackle such problems in the assignments which are going to come. Have a nice day and thank you very much.